Assalamu alaikum. We have a nice exponential questions that is 4 into 2 raised to power 2x minus 10 into 2 raised to power x plus 4 is equal to 0. I need you to remember that this isn't the point. This is actually the coefficients of this number. So this is 4 into 2 raised to a power, it's not 4.2, okay, it's 4 into 2 raised to power 2x, okay, and we have to find out the value of x. Let's go through the step-by-step solution. The given equation is 4 into 2 raised to power 2x minus 10 into 2 raised to power x plus 4 is equal to 0. We can rewrite this equation as 4 into 2 raised to power 2x 2 minus 10 into 2x plus 4 is equal to 0. As we know that x raised to power m whole n is equal to x n whole power m, or it can also be written, this power can also be written as n m, okay? So that is why we just apply that. This is an combined state and we just separate it. So that's why it's become 2x and 2 is actually raised to power. Let 2 raised to power x is equal to a. Now this equation become 4. Instead of this, we will write it as a square minus 10a for this one plus 4. We just replace this 2 raised to power x with a. We can clearly see now this become quadratic equation in variable a. To solve this quadratic equation, we can see that the terms on the left side have 2 as a common factor. So we can take common 2 from this left side terms. So this equation would become 2a square, and when 2 has been pulled out, and it will be 5a plus 2 is equal to 0. Now dividing 2 on both sides, so this gonna be cancelled, this 2 and this 2. So here you go, we will come up with 2a square minus 5a plus 2 is equal to 0. To factorize this quadratic equation, we will first look for two numbers that multiply to give 2 into 2 4, and when a to give minus 5a. So to find out those numbers, we will first look, this is rough work, let me do it. So 2 into 2 will give a 4, and we now here we will make factors of 4, so 4 ones are 4, and then 2 into 2 will give us 4. So we have to make a combinations for numbers. When they get 8, it must give us minus 5. So if we plot minus and minus, but by adding it will give us minus 4. But here minus and minus, so it will give us minus 5. This we can write the middle term minus 5a is 2a square, and this minus 5a can be written as minus 4a minus 1a plus 2 is equal to 0. Now we will group the terms and factor by grouping. If this is one group and this is second, and we will from this group we will take 2a common, so 2a, and here I will left up with a, and here minus 2, and taking minus 1 from here, minus 1, I will come up with a minus 2 is equal to 0. Now we have a common factor a minus 2, so we can take common this a minus 2, so a minus 1 is equal to 0. Now we will use zero product property, and according to zero product property, if the product of two factors is equal to 0, then at least one of the factor must be 0. Now we will set each factor equal to 0 and solve for a. So first a minus 2 is equal to 0. This implies that a is equal to 2. Now we know that this a has been substituted and its original value equal to 2 raised to the power x. So substituting back the value of a, that is 2 raised to the power a, is equal to 2. Okay, so this is the value we earlier supposed. right? And this is 2, so we can write it as 1. So here 2 raised to power x is equal to 2 raised to power 1. When we have the same bases raised to different exponents and the resulting expression are equal, then the exponent must also be equal. Therefore, in this case, the value of x is 1. Now for second term, that is 2a minus 1 equal to 0. We can write it as 2a is equal to 1, and this implies that a is equal to 1 by 2. A is dividing 2 on this side and on this side as well. So a is equal to 1 by 2. But again, we know that a has been substituted and its original value is 2 raised to power x. So substituting back this value, and we will get 2 raised to power x for this a, and this 1 by 2 can also be written as 1 by 2 minus 1. And when it comes to numerator, we can reverse the sign of its power. So 2 will be written as minus 1. So again, we know that the basis of both sides of the equation is 2. Since the bases are same, and we can conclude that the exponent must be equal. That is why x is equal to minus 1. So solution set will be minus 1 and 1. Okay? It is important to check the solution by substituting them back into the original equation to ensure they are valid. Thus, we have this solution set, and the original equation is 4 into 2 raised to the power 2x minus 10 into 2 raised to power x plus 4 is equal to 0. So let's check for minus 1. So x is equal to minus 1. So this equation will be 4 into 2 raised to 2 into minus 1 minus 10 2 raised to power minus 1 plus 4 is equal to 0. So here we have 4 and here minus 2. So it will be 1 2 minus 5, and it can be written as divided by 2 plus 4 is equal to 0. This we can see that this 4 and this also 4 into 1 will get us 4, and 2 square is equal to 4 minus this 2 1s are 2, 2 5s are 10. So here we have 5 plus 4 is equal to 0. Let me see. So this is 1 minus 5 plus 4. So yes, look at this one. 1 minus 5 gave us minus 4 plus 4. Is it equal to 0? So yes, it is equal to 0 and this 0. So by substituting this x is equal to minus 1 is valid root. Okay, now let's check for the second one. To check for this second root, that is 1, we have to put this x is equal to 1 in this equation. That will result us 4 into 2 into 1 minus 10 into 2 raised to power 1 plus 4 is equal to 0. So here 4 and 2 1s are 2, and then 2 square will give us 4 minus 10 and 2 will get us 20 plus 4 is equal to 0. So it gets 4 into 4 will give us 16 minus 20 plus 4 is equal to 0. So at 16 minus 4 is giving us minus 4 plus 4. So yes, this is also equal to 0. So yes, this is a valid solution. This is the verification. For more such questions, do subscribe my channel, and if you have a specific questions, you can ask them in comment section. Thank you.